So today what you're going to be doing is working on creating your own problem. Okay, you're going to be the writer, and you need to make sure that the problem you write can be solved and that it makes sense. It's a real world problem, so you can think about when you might have that. So Maya makes trail mix. This is on your sheet. Maya makes trail mix by combining 1/3 cup of mixed nuts and 1/4 cup of dried fruit. What is the total amount of ingredients in her trail mix? They show her thinking and her work. What I'm asking you to do today is to write a new problem using different amounts for each ingredient. And each amount, bless you, Evan, each amount should be a fraction with a denominator of 2, 3, or 4. Then you can use your fraction strips to solve. All right, go ahead. Stop, because that's not appropriate. Do you need to sit in a different seat? No. Do you need to go for a sensory break? What are you worried about?
Nothing really.
Okay, because you seem very stressed.
Using different amounts for
Okay, do you need to go for a break for a second? Okay, would you like to move your seat? Do you want to sit in the disco chair?
No, I'm good.
Okay, I need you to focus then. Would you like something from your kit?
Okay.
That might be a good idea. Let me get you something. Okay.
These are more. And then half is 50%. That makes sense. Thirds are.
All right, did you guys think of a problem you're going to make yet?
No, I was just thinking of a fraction.
Oh, that's just showing her problem and her ideas. But now you're... Oh, with that one. Do you understand what it means? Okay. Because if you have a question, other people might have it too. No, 2 different fractions of separate materials. Kaden and Abigail, did you think of what you're going to work with?
Oh, we have to work together for this one?
No, you can make different problems if you want. Then you're going to share. But my question is, do you know what problem you want to solve? Because the denominators are supposed to be 2, 3, or 4.
Oh. We're going to do it together?
Did you guys decide what you're going to
Well, we want to do baking.
do? Maddie, not appropriate. You want to do a baking problem? That's perfect. Your denominator should be 2, 3, or 4.
Okay.
Your denominators of your 2 fractions need to be 2, 3, or 4.
Okay.
You got a problem?
Denominator
and numerator. Principal Salerno already spoke to you today. Mrs. McHugh already spoke to you today. What do you need help with so that I can help you be successful? What do you need help with so I can help you be successful?
What am I supposed to do?
You're creating your own problem using 2 different fractions. So you can write your own problem adding fractions. The denominator needs to be 2, 3, or 4.
Can I follow back the back table?
You can, but right now we're working with our partners. Ronan, are you coming up with the problem?
I'm trying to see this.
Okay, but are you coming up with a problem with denominators of 2, 3, or 4? Are they fourths, thirds, or halves?
Yes.
Okay, then start to write what you're adding. I'm here now. What do you need help with?
I'm going to carry across the right this well.
You're supposed to come up with 2 things. You can even model it right after hers. You can say Maddie makes trail mix by combining and decide on what fractions you want to combine. So it can be modeled right after this and you come up with your own fractions. Are those directions clear? Do you feel like you can reach that? Okay, why don't you give it a shot? Did you girls come up with a problem? Baking. Another group is using baking. All right, so what are you adding? What are your 2 fractions you're going to add?
Half and 1/12.
Okay, but they have to be 2, 3, or 4. So half is perfect. We can use half.
Half cup.
So do you want to use fourths or thirds?
Fourths.
Fourths. How many fourths do you want to add? Should we add 1/4, 2/4, 3/4, 4/4?
2/4.
2/4. Okay, so we need one more. Now you have 2/4. Here's your whole. 1/2 plus another 2/4. Ooh, look what just happened. What'd you make?
A whole.
A whole. So let's write down your problem. What do you want to add? What are these going to represent? Are they going to represent ingredients? Are they going to represent musical notes? Are they going to represent an amount of homework you get done each night? What do you want those to represent? A fraction of how many Pokemon cards you have until you make your whole collection. You can make them that if you want.
Okay.
All right, so make them that. So you have 2/4 of what's a certain kind you like. Or you can say 2/4 of a shoebox and 1/2 of a tin in the kitchen. And how many do you have together? Does that work?
2/2 of a tin in the kitchen and a shoebox.
Okay, so then this is going to be 2/4, and this is going to represent 1/2.
And this thing is loose.
That's fine. All right, so start writing. Do you know what you're writing, Ryan? Do you have a good idea? You don't need to worry about anything in here, just this.
Actually draw the picture.
No, you can represent it with numbers. Sorry, Sarah. Perfect.
Help.
You can go on to the next back. Yes. Give me 1 second, Sarah. Snap once, snap twice. All right, I see that some people have written their problem and solved their problem. I'm a little concerned that I see some people with blank pages. When you finish, I'm just gonna okay a couple of people, and then you can continue and work on the share and show. We'll show some possible strategies and solutions in a moment. So, once I've okayed you, you can go on. Evan, you listening? Grace, you with me? I want to make sure you got directions. Leave it for now, listen to directions, get it after. You're working on the share and show. Show me what you know on the back. Some groups are working on task cards. Some are working on planning a schedule or the what's the sum. You may choose. There's also a new enrichment task about musical notes. You may choose what you want to do. I'm going to have some people come back and work with me and then maybe do this sort of success. All right, I'm going to come around and okay you if to move on. Yes, you're good, you're good. Yes, yes, yes.
It's like a baking problem, then what would I put for here?
How much total?
Like how much total ingredients?
Yeah, exactly. You're good, move on. I need a written, composed problem because the purpose of this is so I know that you know how to use it in a context.
Is Colin my partner?
Colin is not your partner today. Sarah, go to the back table, please. Maddie, Ronan, go to the back table, please.
Yeah, I know. It's so fun.
You're good. Camille, you're good to go on.
I'm in the board twice. I don't know what.
Oh, because I switched your partner.
Domenico? Or?
Domenico, please.
I'm working with.
You're coming to the back table for me. Your two are all set? Yes. You can move on. Good. I love that you modeled your problem. You two are set too. You can move on. Billy, you can move on. If you get those done, then I have a laptop saved for you so you can do a central activity. That first though. I want you to do some of those because it's really the application and learning when you use those skills. The cube's right there. All right. We're good? When you have that done, come see me. Kelly and Julia, you were all set. Charlie and Devin, you finished the share and show?
We just forgot that.
All right. All right, I want to model some of these out. You two have great problems going on. You, let's see. Part of this reasoning I really like. I like that you modeled it here, but they can't, oh, they're both fourths? Or did you convert it? You converted it. Excellent, I love it. Okay, I want you to work on some of these. Do you want blocks, or are you gonna try to do it without the blocks? Without the blocks? Okay, I'll have them here for you in case you need them. Go ahead. You have a perfect start though. Can I share your problem? Because I really like it. Ronan, ready? Riley is making platoomy. What? What is he making that for? I don't know about this, Riley. By yeah, since you have some phonetic spelling in here or invented spelling? Do you want to read it to them?
Zafrin.
Yeah.
I'm having a little bit
Okay, come
trouble
sit
how
here.
to do.
I accidentally wrote
I need you, Bennett, look at me. I need you to stop playing with it, please.
I'm not. I'm solving my problem.
Okay, but I'm not sure why you have so many blocks there.
Oh, because I need to borrow fourths to solve my problem.
Okay.
But is it okay? Because I wrote the exact same Maya problem. I just had different numbers.
That's fine. I'd like you to start to think about your own, but that's fine if that you needed that as a template. Turn it off and try a different one. Awesome. Okay, so
I have a different thing.
that's fine. Start working on it.
Okay. I don't really understand what I'm really supposed to do.
It's the same as what you did this morning on the morning work when I pulled groups. Okay, all you have to do is model your problem. All you have to do is model your problem. You're all set. I do want to share this though, so I'm going to keep it. Why don't you work on those ones? All right, Clara.
You want me to come see
Oh, I wanted to see your paper, your written application. All right, so what you're doing is you're creating a problem. You need to either use halves, thirds, or fourths in your problem. What would you like your problem to be about? Excellent, you can go on. Bennett, I need you to put those away and not use them. Unfortunately, you're not using mathematical tools correctly, and it's becoming a distraction. What do you want to add? Oh, you started to think down here. 1/4 plus 1/3? Bless you. Is that what you want to do?
Yeah.
Okay, so now we have to think about what you're going to use to represent these. What is this problem about? What are you adding? Maya did ingredients to a trail mix. You could do something like that, or you could do something different. Okay, let me check you before you leave so that I know that you're on.
I don't know if this is right.
It's not. Model it for me, please, with the base set, the blocks.
Wait, am I supposed to like change this?
Yeah, you have to make them have commented on there, just like we practiced. Do you need a model of one on your paper? No? Yes.
I'm still a little confused. Can I do one about alien spaceships invading Earth?
Sure, can you make it about fractions though?
Yeah.
Okay, then that's fine.
Like 1/2 of the fleet arrived.
I love it, that's awesome. That's great, read it.
The fleet.
All right, what do you need help with?
I'm still confused as
How to add them?
Yeah.
Okay, I'm gonna borrow these because you don't need them right now. So what do you have, 1/4 and 1/3?
Yeah.
Okay. So you're adding 1/4 and 1/3. Now, 1/4 and 1/3 have different what? Denominators. So I can't just add them like that. So I need to think about what I can use, what I can make equivalents to 1/4 and 1/3, where they'll have in common. Then you may move on. Billy, you need to be on task. Colin, you too. Put it in the mailbox.
We should use 8.
No, you need to put it in the mailbox.
Let's use fifths. I'm using 10.
What could I work? Fourths and
Because they're
thirds.
both
Think of
divisible by
multiples.
10 and 2.
Sorry.
3.
Can I make this into thirds? Is there a way for me to find an equivalent? No.
Zafrin, I don't know how to get into Big Central from this.
I think Camille or Colin both could help you with that.
Miss Zafrin, I think there's a problem with these because there's a 1/4 and one.
Okay, but you shouldn't have all different things. You have fifths and tenths. That's all that should be represented. Fifths? Is there any way to make equivalent? No. How about here? No.
How about if you double the 4?
What would that be if you double the 4?
It would be 8. And
Okay.
Then it would be like 4 because 8 is half.
Okay, so I can model an equivalent from fourths to eighths. Can I do that with thirds though?
No, you would have to do that with 6.
But I have to have something that they both work with. But that was a good idea. And I like that you thought 6 for this.
12.
Why maybe 12ths?
Because 4 goes into 12
Okay, excellent.
3 times.
3 times, so 3 12ths.
3 times 4 is 12.
Okay, so does Is 12 also divisible by 3?
Yeah.
Okay. So when I think of multiples, it's all, the directions are all up on the board.
Here's the Mega Man.
If that's what you're, no, not for today. You're not doing that though, that's why you're not assigned that. So Maddie and Brody, 12 is excellent, that's what we're gonna use because it's a common denominator. Why is it a common denominator? Why did 12s work?
Because 4 goes
You need to model what's here.
12.
Okay.
4 goes into 12 3 times.
4 goes into 12 3 times, yeah. So what is 12? 4,
Oh wait, I think I got it.
look at this one with us, Devin.
Okay.
Ronan, look at this one with us. I have, ready, Ronan? I have 1/4, I'm gonna borrow a hole. I have 1/4 plus 1/3. Can you see it okay?
Yeah.
Okay. Brody and Maddie said they tried fifths, they tried a bunch of things, it didn't work. They tried eighths for this, it worked, and sixths for this, but then they were left with different denominators again. So they said, I need to use something different. Brody said maybe 12ths, and he said, because 12 is divisible by 4, and 3 is also divisible by 4. So he said that would work for both. Does that represent the same amount as that?
Yeah.
Yeah, so they're equivalent. Can that be represented by 4/12?
Yeah.
Can this represent 3/12?
Yeah.
So are these two equivalent?
Yeah.
So will the sum be equivalent?
Yes.
Okay, why did 12s work? That's what I want to know. Don't worry about writing anything, just think about that for me. Why does 12s work? 12s work. That's good. Do the work. Don't worry about this or no. That's, I know. Why do you think 12s work? Ronan, I'd rather you be here and not there.
Should I like bring over my own blocks to try them?
No, I want you to just look at this and think. Why did 12s work? Why did 12s work for 4 and 3?
Because
Anyone who, yeah.
because they're equivalent.
Equal each other.
Okay, they're equivalent, they equal, but why do they equal?
Because 3 times 4 equals 12 and 4 times 3 equals 12, so both equal 12 with how much 12s they have on them.
Okay, good. So they both can equal 12, be equivalent to 12s.
And 12s is equal to 1/3, like in length, and 3 12s is equal to 1/4 in length.
Perfect. Why do 12s work?
Because they're small enough that they could.
For the same amount.
Yeah, I could have, they're the same amount, but why 12s? What about 4 works with 12? What about 3 works with 12? Maddie's,
They're
both.
they're compatible.
why?
Because they're kind of like
You can multiply.
opposite of each other.
Because you can multiply.
You could, 4 times 3 is 12, so 12 is a what of 3? 12 is a what?
Divide. No.
Common, no.
Denominator.
No. What?
Quotient.
No. What am I doing to 4 to get 12?
Divide.
I am? 4 divided,
multiplying.
multiplying. So 12 is
12 is a
Compatible.
no, what did you just say?
quotient.
Grace? All right, you should have your own place value blocks. Evan, you shouldn't be touching Grace's things. No. 4, what do you do to 4 to get 12?
You multiply.
4 is a what of 12?
Oh, 4.
Or 12 is a what of 4?
I think he's.
I
looking
guess
for
he didn't
me.
see. He can't come right now. No, he's in the middle of a lesson.
It's a dividend.
No.
Divided.
Are we allowed to
Yes.
on a whiteboard?
No, notebook.
Wait, no, I mean like.
I'm working with the group. I already gave you the directions. You need to do it in your notebook.
When we write in the notebook, do we do a new page?
No, you can do it on the same page. All right. I need you to think about these two problems. What am I doing when I model 4 1/4. I want to make it equal to 12ths. Correct?
Yeah.
What am I doing to 4 to make it equivalent to 12? Times 3, I'm multiplying.
And then you're going to do times 3.
I'm going to have to do that on the top 2, but let's look at 1/3. How do I make 1/3 equivalent to 12ths? I'm multiplying. So if I think about multiples of 4,
So, like,
or multiples of 3, what's on both lists? Multiples of 4, what's on both lists? Multiples of 3, Ronan? What's on both lists for multiples?
There's even.
Nope, what numbers on both lists for my multiples, Brody? 12. Why does 12 work as a common denominator for 4 and 3? Because it's a common, not factor. No, what are we just talking about? What are we just talking about? What are these? 4, 8, 12.
common multiple.
Common multiple. So that's why they work. 4, 8, 12, 3, 6, 9, 12. They have that in common. That's why it works. All right, so let's look at the next one.
Never heard of the word common multiple.
We talked about it 2 days ago. And I know you did it in 3rd and 4th grade. All right. So the first one is 2/5. I'm going to model it right here for you. 2/5 plus 3/10. 2/5. 3/10. 2/5. 3/10. You need to move away from him then. But you need to.
I need to use this box.
Why? We each have our own. Why do you need to use his blocks?
Because you said to put mine away.
Because I don't want you using blocks. So you can do it without them, or you can come sit back here and use them, but you're not doing, okay, then you can come sit back here and do it, but you're not showing appropriate behavior or being responsible for yourself. Can you please put that on the floor? Thank you. Okay. 2/5 plus 3/10. Think about 5ths and 10ths. Sit down. What could be their common multiple?
Common multiple could be
2.
Can I count by 5? 5, 10, 15. I'm making multiples. And by 10. So 10, 20. Am I ever going to get 2?
Oh.
No. What is common?
I'm going to.
Ronan, you need to stop.
Maybe it would be 20.
20 would work,
Yeah.
but it's going to be really big. But 20 would work.
Not 10.
Why would 10 work? You're absolutely right. Why would 10 work?
Because 5 is half of 10.
Okay.
Or
So
10 is half of 5.
you said it earlier first. Okay. So, Brody, so 10 is a what of 5? What are we talking about? No common. What if I count by 5? 5, 10, multiple. And does 10 a multiple of 10? Yeah. 10 times 1 is 10. So will 10 work? Yeah. So if I modeled it, 2/5 is the same as 4/10. 3/10 is the same as how many tenths altogether? 7/10. All right. Go ahead and work on that one on your paper. What do you need?
I don't know how to do it without.
That's fine. But do you think that was helping you, the behavior with those blocks? No. Do you think it was helping you to learn the math? No. Do you think it was helping your group to learn the math? No. And you are very good at math, and you can do this, and you're a responsible person. You need to show that. So I'm going to let you use some of these, but I don't want to see any of those behaviors. Kaden.
Can we use our whiteboards for the test cards?
Yeah, no, I need you to do it in your notebook. I've already clarified that expectation. What do you need? 3rds and 6ths? Okay, go. How'd you do? Good, excellent. All right, what's the next one?
1/2 and 3/10.
1/2 and 3/10. You need to listen to this then too if you're not sure if that works. All right. 1/2. I have 1/2 and 3/10. Okay. I need to think of something that will work for halves and tenths that will be equivalent. What do you think might work? Tenths would work. Should we try tenths? Why would tenths work?
Because 2, 10 with they can go into there's more.
So 10 is divisible by 2, or 10 is a multiple of 2. You can say it either way.
Yeah.
5 is half of 1.
Yeah. So I can do that. That works. Is that what you want to do? All right. So how would you model that?
Well, that's the way that me and Em were doing it. We were just stacking those and then seeing which one like.
But you should just start to think about, without having to stack them, what would work first. You shouldn't have to try each one.
Yeah.
It shouldn't really be guess and check. You should start to think about the numbers.
I have 1/3 because I did 4 times.
That's for a different one. I'm sorry. Which one? We're on this one. Where is that one? Here? Right there. All right. Questions on that one? Ronan, you need to model this on your paper.
Wait, what are we supposed to? Which one is it?
We just modeled this one. 1/2, 3/10. All right.
So it's 7 tenths.
This is 5, 6, 7, 8 tenths. Model that on your paper too. All right, let's do another one. And then I'm going to have you work on a sort of success.
That's 3
5 and 3.
5 and 3/10.
So what's the total? 5
8
tenths plus 8. Yeah, 8. 5 plus 3 is 8 tenths. All right, Ronan, ready? We're going to model the next one. I need you with me.
It's 2/3 and 1/6.
2/3. You with me, Bennett? 2/3. And what?
2/3 and 1/6.
And 1/6. 2/3, 1/6. Okay, now what I want you to start to think, Bennett, is what number do you think would work for thirds and 6? It has to be something. Okay, if I did thirds, is that what you mean? Thirds? If I did thirds, it'd work for the third, it'd work for the other third. Is it gonna work for sixths? No.
Maybe 12.
12 would work.
Yeah.
Why would 12 work?
Because 3 times 4 is 12.
Okay,
and
so 12 is a.
2 is 12.
So 12 is a
12 is a
multiple of
6 and 3.
6 and 3. So 12 works for thirds, and 12 will work for sixths. Right?
Okay.
So how many twelfths for 2/3? Each of these is 4 twelfths, right? So how many total?
I think there's 8.
8, and this is
And that's 2 12.
2 twelfths. So altogether,
Is 10 12.
good. 12ths is not the only thing that would work, though. What else is a multiple of 3 and 6? Oh, I gave away my eraser when I asked you to put that on the floor. 3 and 6. Bennett, list me multiples of 3. Shh, that would also work, but we're not going to go that far.
2,
Not a multiple of 3. A multiple is when that number. Okay.
6, 9, 12, 15.
All right, stop there. 6.
Do you hate erasing with your hand?
What are some multiples of 6, Ronan? Excuse me? 3 is a factor, but not a multiple. Multiple is when you multiply that number. You can use your multiplication chart if you want. What would come next? 6, 12. 18. All right, pause. What's 12 we did? What else is a common multiple of 3 and 6? 18, but we're not there yet, but it would be. What else, though, that's on this list? 6. Could we use sixths? Yeah, watch. Is that the same?
Yeah.
Yeah, so could we say 4, 6 plus 1 more 6? Yes. All right.
It's almost time to switch.
No, actually, we're switching a different time today. It is, though, almost time to close this lesson. So what I want you to do,
Are we doing science next?
what I want let's pause for a second. What I want you to do is we're going to share some of this. I'm also going to assign you a Think Central sort of success. I need you to work on that so that you can feel a little bit more comfortable with it. When is it due? I'll give you a week to work on it. Okay?
Okay.
Because that sort of success lesson is going to continue to practice these skills and use common denominators to add.
Do you have to finish sort of
Success, you will work on it. It's not a long thing. I just don't want to have you start now because I don't think I'll have
Last
time.
year glitch as it would not give you the right answer.
Oh my goodness, I think it's fixed. I think it's fixed. All right, I need you to go back to your seats. And we can leave those.
Should I go?
No, yes, after we're done. Sorry. Awesome. It looks like you girls were working really hard together too. All right, you need to sit down. Evan, how'd you do?
I finished the back page. I didn't get to the activity because
Okay.
then it was.
Okay, are you feeling comfortable now modeling it? I hope that you're working on your work because you two are separate right now. Okay, it looks good so far, but you need to keep going. I'm going to check it online. This looks pretty cool. Did you figure out one that would work?
I counted them both out.
And do they?
Exactly.
Excellent. You were with me. How'd you girls do?
We had 3 more and then we did
Okay. Okay, that's all right. But are you feeling more confident with this?
Yeah.
All right, I'll check it over.
I don't know if this is simplest form.
It is. Because 7 and 8 have no numbers that they're both divisible by.
If I had just gotten like one more an hour, one of them would have been wrong.
You working on task cards? Excellent.
Wait, do we have to do
Yes, not right this second.
something?
Hold on one second. Excellent. Working on success. You were with me, Claire? How'd you do? I hope that you just finished as I was just coming over because that's not what we're supposed to be doing if we finished our math. What were we supposed to be doing? You did that? Perfect. What were you supposed to do when you're done with that?
Me and King were doing task cards for a few minutes, but
But you just finished?
just.
Okay, because that was what you're supposed to be your next assignment. All right, snap once, snap twice. Bennett and Evan, you're not showing me that you're ready. Boys, I need you to clean up.
This one was weird because it made it their numbers up.
Yeah, but that's why it's a little bit more challenging. All right, I want to see 24. Good. All right, I need materials cleaned up. They don't have to be completely cleaned up. I need to close out the lesson, so I need you in your seat. Boys, if you could just move this so nobody trips, and you don't have to clean it up completely, just return to your seats. All right. Looking for people ready. If you're on sort of success, you need to close it out, or mega math, you need to close it out. Finish the problem you're on, it will save where you are. All right. I think this worked really well for you three. All right, I like that Dominic is showing me he's ready. Camille's ready. Ronan, that shouldn't be out now. Thank you. Keep hold of it. All right. Billy? What I want you to start to think of as some people are cleaning up is our essential question. How can you use models to add fractions that have different denominators? That's what I want you to be thinking of right now. Somebody's going to share out. I need you boys to hustle a little bit so that we have you in our discussion. Lily, please don't do that. That makes it not safe for people. Thank you. All right. Hands should be free. Eyes on me. Maddie, just leave those. All right, Molly, Autumn's good. I need everyone here. Seats, hands free. Grace, put it down. Thank you. Thank you, Maverick. All right, question. How can you use models to add fractions that have different denominators? How do you do it? Why can you do it? How does it work? If you had to tell somebody, if you had to answer this question, Domenico.
The models, well, you can use them to compare the sizes of the fractions and see if they're equal.
I love it. So I can use models to compare the value or the size of the fraction to check if they're equal. Who has something else to add? That was a great response though, Domenico. What else, Colin?
I actually had almost the same thing. The
Okay.
models help you see whether the different certain fractions are equivalent or not.
Okay, so see if fractions are equivalent to other fractions.
Yeah.
All right, Maverick.
Well, like, wait, how did the fraction blocks help?
Well, how did using a model? But if you used another strategy, you can let me know.
Just using like the standard algorithm, it was like you could more like see like say like 1/10 times 2 like you. I don't know. It's just a little bit easier for me, I guess.
Okay, so Maverick, I think what you're trying to say, correct me if I'm wrong, but I think you and Charlie and Domenico started to see that there was something you could do without modeling it to find that common denominator and find an equivalent. Okay, so tell me, walk us through that process a little bit. What were you looking for when you did that?
Looking for more like if
30?
there's like a half. If it's like 3/6, I was looking for a half, or like I'll
give you a problem. You see if you can apply it.
yeah.
The logic.
Okay.
Let's say you had
Confused right now.
3/4 plus. I'm gonna make it a little bit more challenging than the
Okay.
ones, but just so you can apply your same ideas.
2/6. So like for that problem, you had to like more like think a little bit more because like I was thinking maybe 6 times 4 would work.
You could do that.
But I found 12 would work for both of them. So
So-
I like
What are you doing when you're thinking of 12 or 24? What are those for 4 and 6? My group at that back table
common
knows.
denominators. No wait.
You're going to make them common denominators, but what is, if I think of the number 4,
Oh, wait,
Maddie,
common
Ronan,
denominators.
Brody,
Common denominators.
Devin, if I think of number 4, 8, 12. If I think of the number 6, 12. What am I doing? How can I find those, Maddie? They're, say the word again?
Common.
Multiples, yeah. So 12 is a multiple of 4. 12 is also a multiple of 6. So those common multiples might help us to find equivalent fractions. We're going to explore that more. All right. So what I want you to do, last thing, in your notebook, I want you to answer this question to me. It will tell me where you are, how you're feeling. It's kind of like a temperature check for today. Addison used 5/6 yards of ribbon to decorate a photo frame. She used 1/3 yards of ribbon to decorate her scrapbook. Which fraction strip should Addison trade for the 1/3 strip in order to find out how many yards of ribbon she has in all? So what they're asking is, instead of 1/3, what would she have to use to find out the total? Doesn't want to know the total, right? What does it want to know? I don't want you to raise your hand on this one because you're going to write it down. That way I know if you know it. What is the question asking for? What's the question asking, not the answer? What's the question asking for, Colin?
The question is asking for something that you could use instead of 1/3 that would be equal to the 1.
So it's looking for an equivalent, but an equivalent that has a common what? Denominator, so that I can do what to those two fractions?
You can
5, 6, and 1/3. What am I trying to do?
You can compare them? I don't know.
I would be able to compare them, but that's not what I'm looking to do. What am I looking to find? Which fraction strip should Addison trade for the 1/3 strip in order to find how many yards of ribbon she used in all? What am I looking for? What's this question asking for? Autumn?
The question's asking for, what you could, change the denominator to
It is. What's
make
this?
it equal.
To make it equal so that it's equivalent to 1/3. What do they want us to do in the end? Why are we making it equivalent, Autumn?
So she can add them together.
Yeah, she wants to find the what, Autumn?
The sum.
The sum or the total. All right, so voices are off. Everyone's doing this problem in their notebook. Actually, do me a favor. Do it on the back of this sheet instead. Just copy it over if you already did it. And then you are going to clean up.
Wait, are we finding the answer?
Yeah, you can put the answer if you want, but what we really want to know is what would be the equivalent to 1/3.
Oh, the equivalent?